Episode 5. Let's get interactive. At the end of last episode, we had started to create the bare bones of our game. We had a box that started and bounced, and then on mouse click, it randomized the position within its draw space so that the bounce wasn't as linear as it was before. In this episode, we're going to look at how to expand on that mouse click interaction and implement others. Interactivity within processing is really limited to whatever you can imagine. There are a massive amount of inbuilt functions such as mouse pressed and key press that we're going to look at later, but really you can code whatever you want based on physical input with things like OSC or serial port information from, say, an Arduino, or all the way through to fully coding it, listening for some sort of JavaScript capture from a JSON file on a website. All these are all things that you can develop into it and use as the driver for your interactivity. What we did last time was implement the void mouse pressed function. Its deep blue color shows that it is a built-in process. Let's make a simple game. So, what this has is it is a simple 500 by 500 square that will draw us a rectangle inside of it. A rectangle that will be drawn at x and y, which we have not defined. As a learning note, you can write variables like this for int x, y, semicolon to define a group of variables at once. So both x and y are both integers that will start with a value of null. If we run the program, we'll see that the square doesn't appear anywhere. I'm also just going to quickly add a background so that our sphere, our rectangle appears black. Using a similar method as to what we explored at the end of episode 4, we're going to make this box randomly appear and move every time we click the mouse. So I'm going to do x is equal to int random width and y is equal to int random height. So in running this, I have put in my x, y, size. I've written the code for my rectangle wrong. So as you can see, every time we click the mouse, the box changed position. This isn't actually anything more than we learned in the previous lesson though. So let's expand on what this does and then turn it into more of an interactive function. E.g., we're going to build this into a semi-game. First thing I'm going to do before I start developing the interactivity is I'm going to change the functionality. So really, what this section of code is doing is resetting box position. We want to use this for more than just one thing. So we're going to take this code and add it to its own function called reset box. And I'm going to take this code and put it in here. And as we learned from our functional video, we know that x and y are global, so this will still interact with it in the exact same way, as long as we call reset box in our mouse pressed function. So now every time I click the mouse, it still resets its position within the space. But before we go on, we're going to add a little bit of tidying up text that is actually a really useful learning lesson. You can see that the random location, e.g. here, this will be like x489 and y100. still is within the bounds of this, but it's actually drawing our square based on the top left coordinate, which means that x location generated is greater than the width take away our size, e.g. 500 take away 50, then we'll lose part of the box. So in our reset section, we're going to add some little bit of tidying up code using one of the loops we learned about earlier to address it. So what I'm going to do is I'm going to check that x is within those bounds. So I'm going to say, well, x is less than, x is greater than the width, take away the size, e.g. 500, take away the size of our box, in this case which is 50, or, which is symbolized by these two up and down lines, x is greater than the width, take away size, or x is less than 0 plus our size, so it's the number generated is 0 between 0 and 50, or 450 and 500. Put all of this in curly brackets. And then all we need to remember from our while loop training is that we need to change the qualifier, in this case which is x, inside our while loop. So I'm going to reset x. X is equal to just that part. So while x. So what does this say? Every time we click the mouse and call our reset box function, it regenerates the x coordinate and then checks whether that x coordinate is within the bounds of, so a 50 pixel border around the edge, if you will. We'll do the same for y, but this time it'll be height. And again, change our qualifier within the while loop. Auto format with Control T, stop it and run it. So now anytime I click my mouse, it will not be able to go outside the bounds of our size. And that is completely dynamic. So it doesn't matter what the size of your box is. So if I change this to 100, it will always replace itself inside the bounds of our cube. There are times that will get super close to the edge. Let me see if I can get one. But it will always be fully visible. And this is going to be important for some of the functionality we're going to add later. So, what we also want to do is we are going to use mouse press as the main interactivity for our game. So we don't want to resetting our box every time that it happens. So I'm going to remove our mouse press function and use something called void key pressed to reset our game. And key pressed symbolized is a built-in function as well, which is shown by its dark blue text. And what key press does is every time that your sketch is running, is it listens for it's called listening, but it listens over the USB port that your keyboard's plugged into for key presses. And when a certain key press is pressed, it then comes back and tells us whether it's valid or not. If we go to the processing reference and search for key pressed, you'll see that there's a whole page on it. And looking down, void key pressed if value is equal to 0, value equal 255, else value equals 0. So what this is saying is that anytime a key is pressed, it's going to check something. This is a very specific way of using it that we're actually going to change. If we look at key, you can see that we can call key pressed in line with other functions, the same way that we have called, or the same way that we called reset box inside mouse pressed. Reset box is a function that exists, we're just calling it differently. Key pressed is going to be called anytime that a key is pressed. And then we can check whether a key is being pressed. Keys are coded in ASCII format, which means that each key has a numerical value. but the built-in keypressed function automatically decodes them and returns it. So this example here, if keypressed, and if the keypressed is equal to the B button in shift mode or not, then something will happen. We're going to use that exact same pseudocode. So inside void draw, we're going to do if keypressed, and you'll see it appears pink the same way that size and height, or width and height do when you call it inside the code. If key is equal to R, or key is equal to R, reset box. Format that. So on running this, if the key pressed catcher catches an R key in either mode, it will reset our box position. Let's test it. So now I'm making sure the sketch is focusing, pushing R, and you can see it resets our box. This also conveniently generates a cool effect where as the R key is being held, it's consistently randomizing our box position. So anytime you push the R key, we get this almost interesting graphic that's randomly generated in real time as our box moves. Now, let's add some interactivity that turns it into a game. So what we're going to do is we're going to reutilize key press and mouse pressed, but for something different. What we're going to do is we're going to check whether the key press is inside the box on screen. And if it is, we're going to make something happen. So I'm going to add something called check bounds. And I'm also going to add something called score. And score by default is going to be 0. What check bounds is going to do is exactly that. It's going to check to see whether our mouse position is inside our box position. So we need to work out two things. We need to get to a few things. The position of the box, position of the mouse, and then is the mouse position within the box position plus minus size. So we need to go know where the box is, we need to know where the mouse is, we need to know if the mouse, that value for mouse position, is within the box position plus or minus its size. So how do we do that? So if mouse x, which is a built-in command for the mouse x location, is less than the x, which is the box's x position, plus size, and mouse x in, sorry, that's mouse y, y is less than the y position plus size, so the top corner plus size, print yes. Now what do you think is going to happen? So you can see that if I'm in this section, which is the greater than the x position plus size and the y position plus size, I do not get a print. However, if I'm in the box, I do. But if I'm in this section, which is technically less than the x position plus size, I also get yes commands. So we need to add a second command that makes sure that it limits it from this side as well. So our x must be greater than the x position, but it must also be less than the x position plus size. So if mouse x is greater than x and mouse x is less than x plus size, enclose that in brackets, and the mouse y is greater than y and mouse y is less than open, open, close, open, open, close, close, open, so now, no matter where the box is, we should only get a yes if we're inside of it. And to do this, so every time that we're outside we'll get no, and every time we're inside we'll get yes. So no, 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 yes, yes, no. Perfect. So now we have a valid check bounds. So every time the mouse is pressed, we check to see whether something is happening. So, using our knowledge of global and local variables inside functions, what we did is we defined a boolean inside mouse pressed, that every time the mouse is pressed, it creates a false boolean called check. We then set check to the value of check bounds, and then using that, we return its true or false value. Inside check bounds, instead of void, we changed it to return a boolean. And then we've created another boolean inside this called check, again, that's equal to false by default. If something happens, e.g. our if statement turns out to be correct, we change check to true. Otherwise, we return it, which by default will be false. What this means is that if in our program, people click outside, we get a false statement, and every time they click inside, we'll get a true statement. But using it this way, as a local variable inside mouse pressed, it means we will only get one true or one false statement depending on the result. Whereas when we hold R, we see the code being called over and over and over again. Mouse press only happens once on command, or on trigger I should say. This is important because we're about to use our score integer to make something happen. So instead of printing check, if check, and this is shorthand code for booleans only. Basically, instead of writing if check is equal to true, we can just write if check or exclamation mark check, which means if check is false, if check is true. Score is equal to score plus 1. running that, we better print score. So now, every time someone clicks inside the box, score equals score plus 1. Every time that the box is clicked inside of, we'll get a point. What we also want to do, after score's been incremented, is if it's true, we want to reset box. So every time every time the box is clicked inside of, it'll add 1 to score, and then it'll reset the box's position. And that is enough on using interactivity to create a more dynamic game. We've used sections from every piece of code we've had so far. What we're going to do is load up our reference. There isn't much new learning here to add, but we're still going to add the code for things like our key press, our internal booleans, and our check bounds sum. So what does our sketch do at the moment? It simply draws a black box. So let's add the functionality that we learned from this. So at the very top, I'm going to add int size x, y, and draw. I'm going to add a new line, and this is called t. Size is equal to 50, x is equal to sets the size and beginning x/y position for the box. We're also going to need to give size 500, 500. And instead of this, I'm simply going to bring in our reset box function. This needs to go in setup. As does this actually. In draw, that's where we put our So now we have a program that randomly generates a box, as well as all the original looping information is behind it. Let's add our key pressed information. Key pressed interactivity. Checks to see if a key press has been caught. Specifically checks for the R key. If the key has been pressed, it runs the reset So now it should have our R variable. And then just as a referencing thing, I'm going to do println box location reset, just because we like to know what's happening. So you should see in between all of our code, if I can find one. So you'll see that it will paste the box location reset, but only at the end of all the other loops. And this is showing, again, the linear fashion in which a program executes. So the key pressed function is one of the last things it actually does before the end of void draw. So this will always appear at the very end of our print statements, as you can see here, if it's valid. So we've included one piece of interactivity we learned about, but I think it's important that we also include this check bounds stuff, although not directly about the interactivity of, although not directly related, learning about local booleans in this way and then the mouse press interaction all add up. So I'm just gonna copy all of this. And then we need to remember to add a integer called score, and then under here we'll set score equal to 0, size of cube, places cube in sketch, resets score. So now if we play this, you'll see we're getting a score of 0. Every time we push in it, our score is being adjusted. And the last thing we could do is, if we go to the very end of draw, and print score, it means it's the very last thing we'll see after each loop. So in our formatting, it means we're always going to be able to see it. And you can see that the function is working properly. Okay, so I'm going to save my reference, close my learning sketch, and then we're going to move on to today's program, which is, as you guessed, is going to be based on this learning, putting this function into this program, so that every time we click our box, instead of it moving position, it's going to move position and increment our score. So what do we need to do that? First thing we're going to do is insert our reset box function. Reset the location of the rectangle. And then at the very start, in setup, we are going to delete this xpos information and introduce reset box. And as a quick cleanup, we need to remember that we don't use x, we use xpos in our main sketch. We don't have size, we also have box W and box H. Box W, box W, box H, box H. So now you can, it randomly adjusts. I also want to add a little bit of a cleanup on our bouncing here, in the same way that we did on our randomizing of the location. Because the corner is based on the top left, every time it bounces outside on this right-handed bottom edge, the box needs to fully go outside before the bounce will trigger. Let's adjust that right now in our check bounds. So if our X position is greater or equal to the width, take away our box width, or equal to 0, height, take away box H. Let's check that. Perfect. So now instead of going fully outside of the square on this edge, the box will perfectly stay within bounds to the pixel, no matter where it's generated. I'm also going to add a piece of code that changes this. If you watch the direction the box is heading, let me just reintroduce the background. You can see, so if we say boxes up left, reset is still going the direction of travel after the reset. What we want to do is change it so that every time that reset box is called, it randomizes the direction as well. Let's have a quick look at how that works. So what we need to quickly do is just randomize the booleans of x, y, and x star and y star. So every time the box is reset, we want to do x star is equal to, this is a bit more complicated than I originally thought, so we are going to create a function called boolean and bool. Random 1 int randomizer is equal to random 1. Mr. Float does not match with type int. Point O. Right, okay, yes. Float. If there we go. So just to explain what I did, we used something very similar to this here, which is a function boolean, we added a function that checks a validity of something and returns a boolean based on it. In this case it's called ranbool, and what we're doing is we're making a float of 1, which means that this will create a value between 0 and 1 in float variables. If that number is greater than 0.5, so whatever half of that is, whatever half of this random value can be, then it returns true, otherwise it returns false. And it runs that for both x and y. So it means every single time that reset box is being run, there's a random chance that the direction of travel is being completely randomized. Brilliant. So that just makes it a bit more engaging and a bit more random in our game, so it's not predictable. The last thing we need to do is implement our int score. Setup score is equal to 0. Print score. And then every time the mouse is pressed, we need to introduce this. The exact same code that we used before. But we already have a check bounce function. So we're going to take this and rename it. And we're going to call this check for score. And in our mouse press, we're going to change check bounce to check for score. Run it. X does not exist. That's x pause plus box w, y pause equals y pause plus box h. Box h. Run it. So now if we're inside our box, we gain a score and the box resets. It's a lot harder than you would think. What I'm also going to do is let's make it a bit more fun. So we have a movement controller, and this controls how fast the box is moving. We set it to 100. The box is going to fly around. So what happens if we do, every time that the box bounces, I'm going to make it slow down a bit so it gets easier. So move box, check bounce here. And then we're going to do move speed change. So what's it called? Movement. Movement is equal to movement take away 5. If movement is greater than 5, greater equal to 5, then make this happen. Else movement equal 5. So now the cube will get slower and slower until it's equal to 5. And then inside reset box, we set movement equals 100. So now we have a cube that bounces down from 100. Every time you manage to click it and score a point, it resets its speed. What I want to do is I'm going to slow down this slightly, so I'm going to do take away 2. So it should keep its speed much longer. And then I'm also going to do, every time that we score a point, score is equal to score plus 1, score is equal to score plus movement. So the higher you click this bot, or the faster the box is going when you click it, the more you'll score. And it's a lot harder than it looks. And I'm going to save that, close this, and that's going to be it for this lesson. So what we've done is we learned more about interactivity and how to make more dynamic interaction with things like mouse pressed, checking for booleans. We added score based on some sort of interaction, e.g. clicking the box when it's moving. And we also learned how to make our program more functional, and really we're starting to use the full power of functions here. One last thing we're going to add is our reset command in draw. So if key pressed reset box. Run it. Reset. Resets the location of our box, and I'll let it slow down just to show you this is actually working. Reset. Brilliant. Save it, and I'll see you in the next one.